working as a associate professor in a engineering college in Hyderabad.
Ah, nice. Okay.
Yes.
Uh,
For improvement of my computing in research paper preparation purpose, I want to join in the Python programming.
okay, I see. Very nice. Sri Hari?
My name is Srihari. I completed my MSc from NIT Bhopal in this year.
Mhm.
So the purpose is actually I don't have a like computing skills, so I would like to enhance those skills. That's
Okay, great, great. Balaji?
Yes, sir. So I'm here. Balaji, can
Yeah.
you, is it audible? Okay. So I am the youngest of all these group members.
Hmm.
I have around 54 years of experience in Fortran.
I
So
see. That must
uh,
make you very young.
very young.
Yeah, yeah.
And also I have taken Python courses at least in NPTEL some three or four,
Hmm.
and completed 16 NPTEL courses and got the
Wow.
domain certification in artificial intelligence, data science, and computational biology.
Okay.
But still, I lack a lot of things. So I thought that I should definitely go through this Python and science, what is going on. And because of my age group, memory is not that strongly retained. So I just wanted to refresh and then see what I can do, etc. So that is the story for all of you.
I see. Oh, that's
I got
awesome.
my
I mean,
I got my PhD from Indian Institute of Science
wow.
long back, and I was in the pharma for 40 years
Oh,
doing
that's very interesting.
research and development. So I'm still interested in learning from NPTEL, and youngsters like you really trigger and then see you're all so enthusiastic. Uh,
We
uh,
try and get inspired by you, people like you.
so I'm still continuing. So for others, maybe interested in knowing, I am 76 years old.
Wow. That gives us energy to, carry on
I am
and
continuing.
learn new things.
Thank
Wow,
you.
that's
Thank you
very
for giving
commendable.
the opportunity. Yeah,
Yeah,
opportunity
yeah. Thank
to
you.
talk to you.
And I also did my undergrad in ISC, my master's and bachelor's both.
Uh-huh.
Yeah,
Great, great to hear.
yeah. Okay, so those who joined later, we are doing kind of an introductory round while we wait for others. So, Aparna, can you introduce yourself and tell us why you are doing this course?
Yes, I'm Aparna Javre. I'm actually now become an assistant professor in one of the senior college, Arts, Commerce, Science College near the Panvel. And this
Mm-hmm.
is my second course in a NPTEL. First course I have done regarding the that research methodology course, and I got the idea about whatever the courses offered by this NPTEL site. Initially I feel it like it's like an online course, then it will not have going to have some weightage, but later on completion of the course and giving the exam, I got the things that it has a level. In the
Mm-hmm.
time of exam also, I was gave the exam in a Pune, so there are lots of checking and everything. It's like a proper examination, not like a online exam sessions, and the things are happen in the many time, whatever the
Mm-hmm.
exams is done in online. So I feel it is a good one and also knowledgeable. I was
Mm-hmm.
the in a previous course, I am the 1% topper in the research methodology course
Wow.
in your side also. My photo and everything wasn't there, and that course is actually amazing. That
Mm-hmm.
problem solving session we have on every Tuesday, and actually that was very knowledgeable, and that
I
ma'am
see.
was very, yeah, supportive. And so
Mm-hmm.
I feel it that contribution for that course regarding that my percentage and everything is by that ma'am who is
Mhm.
taking that problem solving session. That's why I
See.
joined the both the sessions, Sunday session also
Ah,
and this session also.
okay. Yeah, I see. I mean,
Yeah, I'm
not
doing.
to
Yeah.
us also that it's a very good course. Okay, we'll take note of this. Maybe in future
Yeah.
I'll also take that course. Thank you.
Yes, I'm doing my PhD. That's why I done that course,
Hmm.
and my PhD topic is related to the Python. So I feel
Okay.
that this course is also good for me. So I choose it.
Okay. Which department and institute are you in?
I'm doing physics actually. I'm a physics teacher,
Okay, I see.
but my course is my topic is regarding the Python programming, like
Okay.
atomic level, energy level, that
Uh-huh.
with simulator, which is run by the Python.
Okay. So are you doing DFT and that kind of stuff?
Yes, yes, yes,
Ah,
yes, sir. I asked you the query regarding that also. You send me
ah,
the one video link. That is also helpful for me also, because I told you that AI is not giving me the answers for my many of the queries regarding the physics.
right. I mean, when you go to the level of research, I don't think AI is that useful. But
Yes, it's not
for
not.
petty things like plotting and stuff, we can use AI.
Yes, yeah,
Yeah,
yeah. Thank you.
yeah. Okay, anyone left? Nisha, can you introduce yourself?
Yes, good evening. So my name is Nisha Roch. I'm currently a research scholar in NITTE University, Karkala,
Mhm.
and I'm also working as assistant professor in St. Joseph Engineering College. So I've taken up this course because this is part of my course one studies, and this
Okay,
is a 2 credit course for me. And
okay,
I have some basic knowledge of Python, but Python for mathematics in the form of scientific computing is completely new. So since most of the assignments are on mathematics, so I'm actually not aware of how to apply Python and get the solution. That's why I'm hoping that this problem solving session will actually help me complete my assignments.
yeah, okay, okay. Thank you. I mean, yeah, we'll try our best, and I think yeah, the course is designed optimally for you because as we progress, we'll see more and more mathematics and how to solve problems. Python being
Yeah.
just a tool for it. Okay,
Yes. Yeah.
yeah.
Thank you.
Okay, then I think we have covered everyone. Let's start week number 3. Let me see if recording is on. Okay, yeah. Okay, so this is week number 3, and last time we had seen some basic stuff, right? Sequential statement, like a story, you go from one step to the other. But in real life, nobody does this in a serious code because you essentially need loops and all of that. So we learned about if, elif, else, and the loops and functions, which are very useful because for no matter what you are doing, there is something that you want to do again and again. So you define a function for that, and whenever you want it, just call that function. Okay. And then one kind of an abstract thing called algorithmic thinking, which is about being smart and trying to find those kind of algorithms which are optimal, which takes least amount of time or space, or some optimal combination of both, right? So we saw one example which was binary search. So in this week we started with plots. So we'll just have one overview first, then we'll go to coding session. All right, and then we'll do the problem solving. So plots are mostly done using this library, matplotlib. And how do you import library? You say import, then the name of the library, and then give some nickname. So nickname for matplotlib is generally PLT, right? Everyone uses PLT as matplotlib. So whenever you want to call matplotlib, you just use PLT, right? And this is what I think. If you can imagine a plot in your head, right, you can make it on Python because there is so much of everything is available. And if you can imagine, you look up on Google and you will find somewhere that someone has done similar to that. and there are tools available for it, right? So some examples are polar plots, 3D plots, histogram, vector field. We'll do some of this today, and we can do animations, and we can play with pictures also, right? Let's say you have a picture in which there is a lot of yellow, and for some reason you want to make it blue, maybe because you want to increase contrast or something. That you can do using Python as well, although there might be some better softwares for that, but Python can do that. All right. And then we saw how to work with files, right? We can open them, read and write. There are text files, and then you can save files for which has just the numbers, and that is important because when we do coding, what do we store at the end of the day? It's just numbers, right? It could be temperature as a function of position, or something as a function of something. So, and you have different formats available for these kind of files. All right. And we saw that for opening a file, we have a separate modes. So one is R, which is for read, right? And reading begins from the at the beginning of the file, and it does not create any file, right? If there is no file, that it can't read. And if you want to read plus write, you say R plus. Okay, it's same thing, but you can write also. If you just want to write without reading, use W. And if you want to write and read, it's W plus. So the difference between W plus and R plus is that W plus first has the write, so it can create a file if there is no file, right? If I want to write something, I can write on a new page if there is no other page available. All right. So, and there is another mode which is append, which appends the data, which means writes at the end of the file. Okay, so you can only append using A, or you can append and read using A plus. Okay, so you don't need to really remember all of this, but maybe if you are taking exams, you can get a question from this. All right, and then we talked about precision versus accuracy. So what is accuracy? It's that on average it is close to the true value, right? So if you take average of all these targets, it's close to the center. But each of them are far apart, right? So they are separated. There is some standard deviation on this. On the other case, high precision looks something like this. There is very less standard deviation. So it is consistent, but it is far from the true value. And high accuracy means that there is less systematic error, right? And high precision would mean there is less random error because then the fluctuations are very minimal. It's just that there is something which is making all of the arrows go towards this, right? Maybe this lady has a gun which is faulty, and it is slightly curving by zero point 0.2 degree or something, and so the targets are here. So, by the way, don't ask me why are gun shooting these arrows. Okay, it's just the cartoons. And maybe there is this guy. We all know him, right? So he doesn't use any apparatus, etc. But he is a good target, and his gun is perfectly working. So maybe there is some variation, but overall he is targeting the center. So this guy is accurate. This girl is precise. So in numbers, what do we mean by precision? It's essentially significant digits, right? So let's say someone tells you that meet me at 8:30, and another guy tells you that let's meet at 8:26. Now you can imagine that the second guy is being more precise than the first one, right? So what is happening is that you have more number of significant digits. So let's just do some examples rather than going into definitions and all. So 234, how many significant digits does it have? 3. 2, 3, and 4. All of them are non-zero. All non-zero digits are always significant. It's only the 0 that is troublesome sometimes. So you can put decimal anywhere. It's still 3 significant digits, right? Now 0 to 0.34. Now 0 is not contributing to the precision of this number, right? I can write as many zeros here as I like, and doesn't change the fact that it's still 2.34, and I am using a scale. Let's say this is in centimeters, then the scale has this least count of 0.01, right? So it has still three significant digits. 20.34. Now I am adding 0 inside. So of course that is significant, right? So now I have 4 digits. 2.304 doesn't matter where 0 is, it's still 4, right? Now 2.340, which is same as 2.34. So the number of significant digits in this is 3, but it's not, because there is a 0 here, and even though numerically or mathematically both of them are same, this is more precise, right? This is measured using least count of 0.01. This is measured using 0.001. So this has actually 4 digits, and I think professor has made a little bit of mistake here. But all right, so I looked it up online, so and it makes sense, right? This is more precise than this. But if you have zeros on the left, then they don't matter. So 007 James Bond is significant only to one digit. Okay, but 7.0 now has two significant digits because this 0.0 matters. All right, and 7.00040 has five significant digits. So all these zeros matter. Okay, so hope this is clear. This is something that is taught in 11th in textbooks, but for some reason nobody uses it. At least in my career, I haven't seen people using this in UG lab or even in PG labs. I don't know why. Okay, then we went to error. So error is defined as V actual minus V measured. So the actual value and minus the measured value. Some people write it as measured minus actual. So better to look at absolute value, which is just the mod of this. Okay. And relative error is this absolute error divided by the actual value, which means that the error is relative to the actual value. Okay. So on the bottom sits actual value. Okay. Some people make mistake here. This is supposed to be the true or actual value. Okay, and then there are two kinds of errors. We all know about it, systematic and random error. Systematic, as you can think, is related to system that you are working with. Maybe your machine has some zero error, so it gives higher weight or higher anything, right? There is some offset. Maybe your vernier caliper is not giving exactly zero even if you push it to the end. Okay, so that's your zero error. For example, we all know the story of 100 gram, right? Imagine if that were zero error. Hopefully, it was not, but okay. And other reason, if you are doing computation, it could be that our algorithm or method is bad, and that is giving some error, right? So it's not because of this truncation or noise, all these random errors. So truncation is random because first of all it's very tiny, right? Up to 15th or 16th digit mostly for a given number. But when you operate on these small numbers, this error could be large, right? There could be some noise in your system, not for computation, but if you are doing real experiments, there could be some random error. And if you know about chaos, which is what I study, then there is something called SDIC, which means sensitive dependence on initial conditions. So if you are running your simulation for very long, even a tiny bit of change in the initial condition can lead to large separation of trajectories and large error between the true solution and what you found. Okay, so you have to be aware of this, especially when the system is chaotic. Okay, so and the last bit that we talked about is non-dimensionalized. visualization. This we can do perhaps later after coding session. All right. So any questions from this? Anyone? Okay. If not, then let's do some coding. So we start with plots, right? And the first thing that we do in Python code is import the functions to the libraries. So one is import numpy as np, right? And the other one, since we are doing plots, would be import matplotlib and give some nickname. And we know the nickname is generally given to be plt. So we'll stick with it. Okay. And I hope you all are doing this coding, right? Either with me right now or maybe later. But please do this, because just by watching, if you don't already know, then you are not going to learn it. Okay. So, and let's make a simple plot. So, first you need to give what is going to be on x-axis, what kind of numbers. So, we say that it's a linspace from, give the range, let's say 0 to 10. And what do you want to plot? Perhaps sine. So 0 to 10 and number of points. Okay, 100 or 1000. Let's keep it 100 and see. And y is going to be sine of x, right? So NP has this feature that if you np.sine an array, you get an array which has each element being the sine of each element of x. Okay, so it can do this element wise operation, which is very handy. So now we have an array of sine of all those numbers. Okay, and now we want to plot. So I call this library matplotlib plt dot plot x comma y. And what happened? Why is it not plotting?
Sir, matplotlib.pyplot will be
Oh
there.
shit! Thank you very much. It should be pyplot. Yeah. Matplotlib has other features also. Okay, so I got the sign, and then we can play with it, right? We can make it sign of 2x. So what should happen? It shrinks on y-axis, sorry, x-axis, right? So now let's do. We can first of all do this beautification. We can say what is there on x. It's called x label. So I say plt dot x label, and I can put anything as a string. Okay, so this is x, and on y we have, I can either write y or sin x. So now you get x here and sin of x here. All right. Now let me do one thing. I want to get this signal, but it is slowly reducing. The amplitude of this is reducing. So it is an attenuating signal. So I can multiply this by a number, which is some exponential factor, right? So I can say this is minus some k times x. So this k determines how fast the signal is dying, right? So let me give k to be 0.2. Now what will happen? I get a signal that is slowly dying. Okay, maybe we can increase the range and let's see. Okay, so it goes to 0. Now I want to see how this envelope is going, which we know it is np dot exponential, right? So let's plot another plot, plt dot plot, which is x and np dot exponential of minus k times x. So now it shows this envelope, right? Now I want to tell the people, those who are seeing the plot, that the orange one is this and blue one is this. So those are called legends, right? So we have to give a label to that. So this x comma y, that we can say the dying signal, and this one is the, what do you want to, the death factor or envelope, if you want to be, sophisticated. Okay, what happened? Is it the space? Oh, it should be just a string. Is it? Okay, don't know what's happening. Let me just give it. I should write label. This is label. Okay, this is the signal. And even if I give label, it won't show because I haven't told the plot to show this label. So for that, I have to tell it plt dot legend, not legends, legend, and then run it. Okay, so now it automatically decides what is what, right? Because we have told it that this y is signal. So whatever color it chooses for y, which is blue, it gives blue to the signal and orange to this death factor. Okay, so you can do all sorts of things. You can change the color, you can change the line width of this, make it stars or dash dash, etc. Right? So and let's do one more example, which is what I was talking about during the last week. So if you remember, last week we started with this simple else if, and then at some point of time we made a function for sine of x using this Taylor expansion, right? So let me just copy this and let me define it to be a function. Okay, so I have a function def func, and let's call it sine Taylor, right? It gives the value of sine x approximated using a Taylor series up to the exponent n, right? So this was the code, and instead of printing we will return it, right? So let me just run it, and yeah, function should have a colon. I said that 100 times last time and I myself forgot. Okay, now let's just do a sanity check. Let's evaluate it at pi by 2. So np dot pi divided by 2 up to say 20. It should be close to 1. It is exactly 1 because maybe the difference is at 20th digit or something like that. So if I use a less number of terms, yeah, you get some error, right? But it is close to 1. So now we can try to plot this function versus the real sine, right? So how do we do that? So we can say that there is a list which we call n list, which is the number of terms that we want. Actually, n is not the number of terms. The way we have defined it is the maximum exponent it can take. So let's say 3, 5, 10, and 20. Okay. And now for each of these m, so for n in n list, I want to plot something. What do I want to plot? Taylor. So I say y Taylor is equal to Taylor's sine, sine Taylor. This is the function that is evaluated at x up to term n. Right. So we have to tell it what x is. So np dot linspace from 0 to, let's go up to 2 by roughly 6, right? And say we have 1000 points. And now we plot plt dot plot x, and on y-axis we have y here, right? And so yeah, let's start with this. Okay, so as you can see, some of them, all of them diverge, but some of them diverge quickly, some of them take some time, right? And the other thing is that we know that real sign stays within -1 to 1. So let's put, first of all, let's put a real sign. This is plt dot plot x comma np dot sine of x. Okay, and one thing we can do is limit on y-axis. So plt dot ylim, I want this to be -1 to 1. So in bracket I give an array -1 to 1. Okay, but now there is one trouble. We don't know what is what, right? We know that there is probably this purple one is going to be sin x, because it looks like that. But in general, we don't know. So again, we want to give some label. So I give label. Now, how do I give a label? I want to tell that it is n is equal to 3, this is 5, this is 10. So I use something like this. First I say f, and then I can write n is equal to, and in curly bracket, and so whatever is in curly bracket is actually the variable that is to be put inside the string. Okay, and for this also I can say label, this is the real sign. And as usual, I forgot to put legend. plt dot legend, bracket open, bracket closed. Okay, so now as you can see, the blue one is the first one to depart, right? Because it is just 3 terms. So it is x minus x cubed by 3 factorial. So it's a cubic equation. Then we have power 5, so that stays. And then power 10, which is green. And then there is red one, which is missing. And then there is purple one. Now why are we not seeing the red one? Anyone? Why are we not seeing red one? Something wrong with the code or something wrong with the math? So let's do one thing. Instead of 6, let's make it 12. All right, and now we see the red. Okay, so what was happening is that n is equal to 20 is so precise, which we actually saw by the way here, that it was almost coinciding. And since the real sign was the last one to be plotted, right? So that's why we were seeing only the purple. The red one was hidden inside it. And then it departs at about 7. Okay. Yeah, so this is something that we can do. Now let's compare it with higher numbers. Let's make 20 and 30. So as you can see, 30 even goes till higher ranges. So as you increase the number of terms inside, it becomes closer to the real curve on a longer and longer range. Okay. So by the way, you can use any function and make a Taylor expansion, right? And you can play with this. Okay. Any questions so far? Okay. If not, let's do one cute example, which I'll call onion. Okay. The task is to plot on, we have how many? 10 plus 10 minus 1, 19 curves, which will be from 0 to 1, and it is x to the power 1, which is the straight line, then x square, which is slightly curved, then x cubed, more curved, and all the way up to x to the power 10. So I get the lower half of the onion, and then I do square root of x, then cube root of x, etc. Okay, so all of them start from 0 comma 0, and then they diverge and come back at 1 comma 1. Okay, so first, as usual, we define x, np.linspace, and this time we just want from 0 to 1. Okay, and let's start with 100 points. And now for each of the n, so I have 1 to 10, right? For n is equal to, so n in range, and I don't want 0, I want 1, and I want to go up to 10. So I should write 11, right? And then colon, and then for each n, we first define what yn is going to be. It is x to the power n. Okay, and then plt dot plot x comma y n. All right, let's see what happens. Yeah, so we got the lower half. Starts from 0, 0, ends at 1, 1, 1 for each of them. So this is y is equal to x, this is x square, this is x cube, etc. And the last one is x to the power 10. Okay, and to get the upper half, I just make x to be 1 by x, right? So, sorry, n to be 1 by n. So I do the same thing. Let me copy paste. But instead of x to the power n, I go 1 by n. Alright. By the way, there is an option for choosing whether you want to see this indentation properly or not. Okay, so if you are a beginner, this could be useful. So now, if I run, we see the entire onion. Okay, and what will happen if I increase this 11, let's say to 31? It goes towards the square, right? Because x to the power 31 is almost 0 for all of these values, and very close to 1, it suddenly becomes 1. Alright, and now you can put legend for each of them, but it will get very messy. Okay. So let's do one more example for plot. This time I want to I want to plot this y is equal to x to the power 1 by x. Okay, so this is what I want to plot. So first I define x as np dot linspace 0 to what range do we want? Let's say 10 and 1000 points. By the way, what happens if we reduce this number? So let's say here we had 10, 100. Let's make it 10 and run it. Yeah, it becomes cornier, right? Because now you have this corners because you have less number of data points. So you start with 0.0, then you have 0.1, etc. Okay, so always a good idea to have this number big. Yeah, if you want your graph to be smooth, but if you make it too big, then it will take obviously longer. So you have to be wise in selecting how many points you want. Okay, so let's keep 1000 points here, and the function is x to the power 1 over x. And now let's plot it. So plt dot plot x comma y. And if you knew the function, you know that there is a maxima, right? If you don't, then you can just see by yourself there is a maxima somewhere around here. Okay, we can increase the range to 100, and yeah, there is a clear maxima here, and then it keeps on reducing. Now let's say for some reason we want to find where the maxima is, and we want to plot we want to see it on the plot itself. Okay, so we can get the maxima. So y max is just max of y, right? So max is a function that comes in Python, so we don't have to give any np thing. Okay, and we also want to know where that maxima comes. So on x-axis, so we want to know the maximum value and the maxima, right? So we can say x max, or let's call it maxima, is np dot argmax, okay, of y. Now, what will this give? Because y is an array, it will give the index of y, where y takes the maximum value. Okay, so since we have how many 1000 points, and this is around at 2 or 3, this will be something around 200 or 300. Okay, but we want the value of x. So we say that it is x at that index, right? So x of 200 or 300, whatever it is. And now I want to plot lines at that maxima. So let's say I want to plot one vertical line here and one horizontal line here. So how do we do that? Prof discussed this, right? Plt dot ax, and if you want to put a vertical line, it's a v line. Then tell it where you want it to be. So x is at maxima. Okay, so let's run this, and you get a line. This is the maxima. All right. And if you don't believe it, because to my eye it looks like it should be slightly to the left. Okay, so let's put horizontal line. So for horizontal line it becomes h line, and then y is equal to y max, right? That is the maximum value. Okay, and then you can see that it is actually maximum. Okay, and of course you people like dashed lines here, right? So if you want dashed lines, what do? Call that line style, style. is equal to dash dash. All right, and maybe you want to give a color, different color. Color is equal to red. So you get a red dashed line at the maxima. By the way, let's look at the maxima. It is 2.72. So what is that? Any number close to this that comes to your mind?
E.
E, right? The natural number E. Okay, but it's not exactly 2.718, whatever it is. Why? Because we have just 1,000 points, right? So if you use more number of points, it should ideally get closer and closer to this. And then it becomes the question how good Python is at evaluating this function. Okay, so and you can directly check on pen and paper, right? If you take log of this and then differentiate, make it equal to 0, you will see that x is equal to e. All right. So the point is that you can do all sorts of things, and then we learned about subplots. So if you have seen any research paper, you don't have just one figure, right? You have figure A, B, C, D. So you want subplots. So that is already discussed in the lectures, but let's do one example where we have four subplots. There is one function, then its derivative, and second derivative, and third derivative. All right, and we'll use slightly different way. So first we define a function. So f of x, so that we can vary it later. So right now let's put a simple function. Say x to the power 5, right? Because we want derivatives and second derivative, third derivative. That's why higher power. Now x we want from some in some range. So np dot linspace and 0 to 6. Let's make it -6 to 6 because the derivatives, first derivative and third derivative would be even, so we can see it. And let's make 100 points. And now I want to first get f of x, right? That will be our first plot. And I want the second plot, we can call phi2 or dy, let's call it dy, which is going to be difference of x, f of x divided by difference of x, right? Delta f by delta x, because computer can't differentiate, all right, analytically. So it will do for small x delta f by delta x. So the difference can be calculated using this np.diff of f of x. So this is y in our case, and then I want divide by dx. Now what is dx? It is just np.diff x, right? So I hope this is clear. So np.diff gives difference of consecutive elements, and since this x is linearly spaced, this is going to be a constant array, right? And one thing to remember is that whenever you do np.diff, the length of the array decreases by 1, because if you have 5 elements, you have 4 differences, right? That way. So now again you can do the second derivative, which is going to be np.diff of dy divided by np.diff dx, or we can use just x, but we have to remember that we should only go up to one place less than the entire length. Okay, so it is x of minus 1, and then we want the third derivative. So d dy, which is going to be np.diff of d dy, and np.diff. Now again, when we do diff, one length is reduced, right? Length is reduced by 1. So now we have reduction of 2. So we go up to minus 2. Okay. Now I want to create plots. So I say fig, and x is, and then I want subplots. So plt dot subplots, and then give the dimension, the matrix that you want. So it is 2 cross 2, right? 2 rows, 2 columns, and you can give figure size also, but let's not do that. Now we fill this axis. Axis is like a matrix, right? It has 0 0 element, then 0 1 element, etc. So 0 0 is going to be the top left element or top left plot. So on there we are going to plot x and y. Alright, and then on axis 0 1 plot. Now we can't plot x and dy because x has one length more than dy. So we say up to minus 1. And let me just copy paste this for the next one, which is 1 0, where we plot d dy. So I need up to minus 2, right? And for 1 1, which is the last plot, it is going to be d dy will be minus 3. Okay, now let's run this. Whatever. Oh, why did I write like this? It should be y is equal to, right? And return y. Yeah. So now we have x to the power 5, then x to the power 4. So 5 times x to the power 4, then it will be x to the power 3 with some coefficient, then x square, right? So, and then you can, if you want to say some title, you can set title. So x is 0 0. Again, instead of plotting, we are setting the title. So set title, and let's call this position. So the next one will be velocity, and the derivative of velocity. So assuming that x is in dimension of time. Okay. So acceleration, and the last one, I should change these numbers. So last one will be the derivative of acceleration. What is it called? Quiz time. Derivative of acceleration. I think it is called jerk. Okay. Not that it matters for science, but so now you have position, velocity, acceleration, jerk, etc. Right? And since we have fx defined, we can change this. We can make it exponential. Np dot exponential of x. And what will happen? All of them are same things, right? Because derivative of e to the power x is just e to the power x. Okay. But as you can see, they don't seem to be exactly equal, because here you have up to 400, then you have up to 300. So either scale is shifting a little bit, or something is happening, because of which we are not getting exactly same plot, even though mathematically they are the same function. So why is that happening? Because we are not actually differentiating, right? We are using this four-screened method, and that's what we can do, right, using computers or any discrete thing. So and this is an example of systematic error. So if we compare these values, they will be almost same, but may not be exactly same. Okay. Nonetheless, it does its job, right? It's pretty decent. And let's make it 2x, exponential of 2x. Now what will happen? So it should be the same function, right? So e to the power 2x derivative is e to the power 2x. So again you get the same function, except that the y-axis changes. So it is now 30,000, then up to 50,000, 80,000. So again what is happening is that you have 2x, so its derivative is 2 times e to the power 2x. Then again 4 times e to the power 2x, etc. Okay, so this way you can create plots, okay, subplots. And by the way, you can also get this derivatives using a function that has a function as an input, right? If you remember, that was discussed in one of those lectures in first or I think second week. So you can use derivative of function at x, which is a function of x, and the function that you want to differentiate, and then again differentiate that function. Okay, so maybe that's something that you can try out at your home. Now let's see 3D plots. Okay, 3D. So essentially there are three kinds of plots that people generally use, and so you give first of all x, right, your base, or what is it called, your independent variables. So let's say -3 to 3 with 100 elements. Now you have to give y also, because a 3D function is function of x and y both, right? So let's say y is say np.linspace. I forgot np. Okay, and next thing is to create this mesh grid, which is the matrix of base values. Okay, so np.meshgrids x comma y. So now you mesh grid. And so now we have this flat mesh grid over which the function will be evaluated. Okay, so we can define a function, any kind of function. So the one which was, and it should be function of this capital X and capital Y. Okay, so you can say x plus y. Let's make it 2x plus 3y. So just a linear function. And if you are curious, you should begin to imagine what it could look like in 3D. Okay, so uh, so say now we want three plots. Okay, again subplots. So first we define a figure object and tell it that. So this is the way I think the professor does, and we can give it some size also. Figure size, fig size is equal to something 18,6. So it's 18 inches wide and 6 inches high. Okay, and now we keep on adding the subplots. So, and each of them is one axis, right? So first one is first axis, So we are adding it to the figure. So add underscore subplot. And where do we want it? 1, 3, 1. So 1 comma 3 is how we want it horizontally. Right, so we have one row and 3 columns. And this is going to be the first image. Alright. And then let's plot contour. Okay, call it CP contour plot. And that is being plotted on axis 1. So contour and on x-axis you have x, on y, on z is the function which we have defined as capital Z. Okay, and now if we run this, we get the contour, right? But we want to know that what does this mean? What does this line mean? All we can say, if you can imagine, is that there is some kind of upward slope in the right top direction, or it could be downward slope, but slope is in that direction. Okay, but we want numbers here, so that for that we have to tell it ax1 dot c labels for contour, and that then tells the axis the plot, and inline is equal to true, which means it's going to give the numbers on the line, and you can give some font size also, but let's not do it. Now it should give numbers. Okay, so now we know that this line is where the function is 0, this line is where it's 4, this is where it's 8, this is where it's 12, etc. Okay, so if you can imagine this to be height, then we have steps for this one, for this course grid, right? We know in reality we have upward slopes in the top right direction. Okay, now let's make the second plot. I'll copy this. So x2 is going to be the second plot. So it's 1 comma 3 comma 2 and 3 2, and this is going to be a density plot. So ax2, and we'll use im show. So it will treat the matrix as an image, and it's trying to plot that image. Okay, so the value is going to be z, and let's just try this. Okay, so again we have a gradient. Okay, but the issue is that we have 0 to 80 on y-axis like this. Okay, because it's an image is generally plotted as on y-axis it is ulta, reverse. Okay, but bearing that, it's same as this one. So we can write, if we want it to be as like as equal to this one, then we can write extent to which we want. So we want -3 to be to 3, right? And on y-axis also it's going to be -3 to 3, and yeah, and do we not, do we need something else? Yes, it's same as what happened in the earlier case, right? We didn't have numbers, so we knew that something is going on in this direction, but we can't say that quantitatively, so we put numbers here. Now this is an image, right, or a heat map as it is called, so we need a color bar. So that green means this, dark blue means this, etc. So that is called a color bar. So fig dot color bar will add a color bar to this plot which we have called dp, right? And where should it be put? On the second axis. Is there some issue? Oh, I intended to put it on the density plot. Okay, so now we know that it is minus 15 here and plus 15 here. Okay, and because it is IM show, it is a transpose of this. Okay, but transpose along the other diagonal. Alright, and third one is a surface plot. So for surface plot, going to be 133, right? And surface plot is SP dot. So SP first we define, it is going to be on third axis, AX3, and there we are plotting a surface, plot surface, and then we need to give X, Y, and Z, correct? And again we need to give color bar, pick dot color bar to which plot? The name of the plot is SP, and where do you want to put it? On X3, right? Third axis. Again some issue. I don't know what's happening. Oh, I have to specify using this because there could be other keywords. Still not working. Okay, I don't know what is happening. Does anyone know? Can anyone resolve this?
Any library or kind of thing?
Yeah, but it should already be there. I don't know why it's not there. Okay, let's just quickly search. Maybe you are right. Let's just Google it. Oh yeah, maybe it needs this one. X dot plot surface. That is what we did, right? Yeah, so let's just import this. Still no. Never mind. Let's do this the next time. I'm sorry, I thought plot surface just works because it used to work probably. Anyways, sorry about that. So we'll have to do next time. Okay. And perhaps you can also meanwhile find out what is wrong with this one. Uh, now, do we want to do any graphs or everything is clear? Any questions so far? If possible, please increase code font. Oh, okay. So the thing is, I don't see the chat box, so I didn't see it. Sorry, I'll increase the font size. Okay, is this okay? Probably he left. Okay, what else did we do? Vectors, vector field. Okay, so it's again same thing as this. So we can define x and y as mesh grid. Yeah, what we want to plot is some vector field. Okay, it could be a vector field of a mass that, and the field is the gravitational field. Okay, or it could be a dipole or quadrupole, something like that. Or it could be a vector field of a dynamics of a particle. So how x and y are changing. So joining all those arrows will give you the different sorts of trajectories. Okay. So first we define the mesh grids np dot linspace. So I'm not doing x is equal to np dot linspace and then xy being the mesh grid of that. Okay, I'm just doing it using a shortcut. And let's say up to -5 to 5 and 100. Make it, let's make it 20, and same for y. So now our xy is going to be between -5 to 5, and then I want to define a field. So x dot, which we will call u, let me call it y, and v as -x. Okay, there is a reason why I am doing this. And then I want to plot on every point on this mesh grid, set xy, an arrow which is pointing in the direction of u comma v. Okay, so the in x direction its component is u, in y direction it is v. All right, so plt dot, and I want to put an arrow, so the function is quiver. All right, now let's do this. And what should be the answer? How should it look like? Looks like circles, right? And what is the result? Have you seen these equations anywhere? Let's call this dx by dt is equal to y, and this one is dy by dt is equal to -x. Okay, so are those equations familiar? These are the kind of questions that are asked in interviews, right? So if you see if x is say position, then y becomes velocity, and then dy by dt is just acceleration, which is proportional to -x. Okay, so this is an equation for a spring mass or a simple harmonic oscillator, and we know that in phase space it looks like ellipse, right? So and the mass and the frequency will, or the spring constant will determine how eccentric it is. Now since I have just used 1 and 1 as coefficients, it's just circles. Okay, and there is a way to prove, very simple way to prove that this will produce circles. All right, maybe we can do that towards the end. So that's a simple thing. So yeah, you can do all sorts of things with plot, but now let's do things with files. Okay, because that was one of the topic that was covered. So Python can have an object which is a file, and it can be created, it can be opened, can be closed, etc. Right? So let's call first file that we are going to deal with file1, and we want to write it, right? Because we don't have anything called file1 right now. So we say open and then give the name of the file. So I don't know, my file, all right, and .txt, it's a text file. And as we saw earlier, we have to write it, right? Because it's a new file, so we cannot read it. It doesn't exist in our ensemble. So first we need to write it. Now, whatever we want to write it, we can first say it is some string or array of string, right? Hi, hello, or rather, let's say for hello world. That's the tradition, right? Whenever you start coding, you first type hello world, and if you want another, bye world, and then I want to write it on the file. So I say file1 dot write lines in bracket L. So it's going to write all the lines that L has. Okay. Or I could have directly written in this using file1 dot write. Okay, your wish. And then, as Professor mentioned, it's very important to close the file because this writing happens in the RAM. So to save it, you need close. Maybe in Colab it works without closing, I don't know. But it's a good idea to close. Okay. So yeah, there is no output because we didn't print anything, but something happened, right? So we opened a file, a new file called myfile.txt, and Python, this code recognizes as file. Okay, so this is a Python object, and this is the real file that is on the computer. And then we wrote two things, hello world and bye world. Then we closed it. Now on Colab, it is saved on this folder. So now you have myfile.txt. If you do it locally on your computer using Spider or Anaconda or whatever animal you like, then it will be stored on your computer. Okay, and you can open it here, and you get hello world, bye world. All of them are together because there is no space or dash n, right? So there is no new line either. Okay. Now let's do one thing. Now let's append something in this. So now I say file1 is equal to, first I'll have to open it again, right? Because I closed it. So open my file.txt. Now I don't want to write because writing means we start from beginning. I want to append something. So I say A. A. And now what do I want to append? That is said by file1 dot write. So again I am writing, but since I appended, my cursor would be at the end for the pointer. Okay. So this will stay intact, hello world, bye world, and now I can write anything. Uh, it's boring. Okay. And now, and let me add slash n here. Let's see if it appends with a new line or not. Okay. And again, file1 dot close. And now when I run it, it will first open this with write and again write it. But with write means this will be erased and then will be rewritten. So it will be same as this one and then it will be appended. So now on the next line, because we have slash n, it has appended, it's boring. Now let's open it again, but with a write. Okay, and now let's write something. See what happened. So it will write, see what happened. So what will be the output of this one? It's just see what happened because we started with W. It's just gonna start writing from the beginning. Okay. Now just to see what read does, let's open it with reading mode. .txt and R, and then I say file one. I want to read it, right? So file one dot read, and I want to print it. So print, and then I close the file. So it prints it here. So the difference between this and this is that this is actual file where it is stored. You can download this file. This is just in the result section of Python, right? Like the terminal. Okay, so you can do R plus, A plus, and you can play with this. But you get the idea. And one last thing is that you can use with also. So I don't remember the structure, but so what happens is that many people don't like this closing thing because you forget. But if you have indentation, then you know that this is one section for file. So that is what you can do using with. So you can search online. But if you have with file one open, something like that, then you don't need to close it. Okay, it becomes a loop, like a for loop kind of thing. So it's not a loop, but it gives the indentation. And there is this one section where the file is opened and closed, and everything happens in that section. Okay. So, alright, I think enough of coding. It's already 7:20. Now let's go back to the presentation. And one thing which remained to be discussed was non-dimensionalization. And this is where we kind of step into the real science, right? Because so far we have been just plotting and doing loops and everything, which computer science people also do. Okay. So for non-dimensional, let me open a Jamboard. Uh, so professor already did an example, right? One or two. So does anyone have question in that, or should I discuss a new example? Okay, I will do one new example. And there is one question: what's the difference between A plus and W plus? So when you do W plus, your cursor would be at the beginning. So if you write something and there is something already in that file, that will be lost. But if you do A plus, then it will be appended at the end. So whatever there is will be staying. Okay. So it's same as A and W. Plus just means that you are going to read, you are going to be able to read it as well. Okay. And how the number in add subplot is assigned. Okay, yeah, it's a good question because I can answer it. So where was subplot? Yeah. So the first number tells you how many rows are there. So we want 1 by 3, right? We wanted something like this: 1 column and 1 row and 3 columns. So this is 1. The second one is the number of columns, which is 3. And the last one tells you that which one do you want right now. So for second graph, we want it to be at the second place, right? If I make this 131, and this is 132, then they will be switched. Okay, so now the contour plot is at the second place because it is 1, 3 and the second place, and this is 1, 3, the first place. So 1, 3, 1. Okay, any other questions? All right. So first of all, we saw why should we do non-dimensionalization? Because we get rid of parameters, right? Parameters are bad for computations because you can have one parameter which could be the size of nucleus, which could be 10 to the power minus 15. Okay, and if you work in that unit, then you are going to get errors, and they are going to be magnified because that's where the boundary of computation lies, right, for our usual laptops. Okay, so we want that we want to absorb that 10 to the power minus 15 factor outside the computation, and maybe at the end, if we want it, we can uh, eject it back again, but we don't want it during the computation because that could lead to errors. Okay, so just to give you a basic idea, let's do one example, which is this. Just a second. Don't know, my stencil is not working. Yeah. So I'll have to use some notebook. So I'll stop presenting, then I'll present again because I want to present something else. Can you see the notebook?
Yes.
Yes. Okay, thank you. So the problem that I want to discuss is this one, dx by dt, which gives you the velocity, right? And the velocity is a quadratic function of x. So ax plus a plus bx plus cx square, something like this. And it has three parameters. And we want to reduce the parameters basically. So the first step is always to identify the scales. So how do you identify? So there are two variables. There is x and there is t. So we want x0, some scale for x and some scale for t. So for that you have to compare different terms. So as you can see, this is constant and this is something with x. So if you compare those two, you will get a scale for this. So you say that dimension of A is going to be dimension of B times dimension of x. Okay, which means that dimension of x is dimension of A by B. And that gives you one scale, which is for x. By the way, there could be multiple scales also, right, for the same quantity, but this is definitely one of them. So you say that x0, which is the scale for x, is a divided by b. Okay, that is one. Now we need for time. So there is no time on right hand side, but there is on left hand side. So there is x over t, and then there is this term which is just x. Okay, so we can compare those two. We can compare any of these NC2 terms. Okay, because all of them are supposed to have the same dimension if the equation is dimensionally correct. So that's, I can say, is b times x, which means, so the dimension of dx over dt is going to be just dimension of x over t, right? Because this differentiation doesn't matter, so it's still going to be meter over second. And then you get the dimension of t, which is 1 over b. So that scale sets a scale for t, which is 1 over b. Alright, and now we want to scale our variables. So we say that x is x0 times a variable which represents the position but it does not have any dimension. Let's call it psi. And there is time which is going to be t0, the scale. So this says the unit of seconds or hours or years, whatever, and times this number tau, which is the variable. This is constant but has units, and this is non-dimensional, right? This is by definition non-dimensional because we know that we have selected t0 such that it matches with the dimension of t. Okay, so now we will simply put this in our original equation. So we have d of x is x0 times psi divided by d of t is just t0 tau is going to be a plus b. X is again x0 times psi plus c times x square. X square is x0 square psi square. Okay, so at the end what we should get is some equation which should be d psi by dt being some function of psi, sorry, not t, tau, right? Rescale time psi tau and all these parameters a b c whatever it is. Okay, but hopefully it won't have all three independent parameters. It will have less number of parameters. So x0 by tau 0 t0 comes out because they are just constant. So d psi over d tau a plus b x0 psi plus c x0 square psi square. So 1 x0 cancels. Oh no, we have a. So let's go to the right hand side. So let's send this to the right hand side. So a times t0 by x0. I know all of you can do it, but this will be uploaded on YouTube, so we don't know. Maybe a 12th grader will see this one day. Okay. So this is p times x0 times t0 divided by x0 and c x0 square t0 divided by x0 xi. Okay, so on left hand side we already have what we wanted. On right hand side, now we can put the value of these scales t0 and x0. So t0 was 1 over b, x0 is 1 a by b. So a t0 is 1 over b and this is a by b. And this gets cancelled. So b times t0, right? And there was one psi, this one. t0 is just 1 over b psi plus c. This x0 gets cancelled, so it's x0 times t0. x0 is a by b, t0 is 1 by b psi square. Okay, and now something beautiful happens, right? It always does. So a over b cancels, pb cancels. So you have 1 plus psi plus ca over b square psi square. Okay, so we started with an equation which had three parameters here, yeah, a b c, and now we have just one parameter which is this I can write this as 1 plus psi plus alpha psi square. Okay. So it does not matter independently what C, A, and B are for how the problem, how the solution will be. It's this combination that is relevant, which means if I have C is equal to 1, A is equal to 1, and B is equal to 1, that will give alpha as 1, right? Or I could have C is equal to 2, A is equal to 2, and B is equal to 2, and that will also give alpha as 1, which means both of them will have the same solution, except that on time axis on x axis they will be stretched and shrunk according to these factors, but the form of the solution will remain same. Okay, so I hope that is clear, because these are the kind of questions that you will be asked in the exam also if you are crediting the course. Okay, any questions? Okay, if not, then let's solve the problems and call it the day. Yeah,
Am I audible?
yes.
How do you decide the T naught and X naught in a real problem?
Yeah, so as I said, two things. First of all, they need not be unique, right? If you have, let's say you have a problem in which you have two frequencies, and for each frequency, if you do 1 over f, you get a T naught, right? So in many cases, you have two time scales, one fast and one slow, and then you have to be wise and think what time scale do you want. If you want to see at very small time scales, that is when things are moving fast, then you choose that scale. If you want to see how the galaxy evolves over billions of years, then you don't worry about what is happening, these fluctuations at order of 1 year, right? Then you choose that time scale.
Okay, thank you.
Yeah, yeah. But how to determine what time scales are present? You compare the terms. Okay, you can compare this two or this two. Okay, for example, if you compare this two, that will give a scale for x as well, which will be b over c, and you can solve using that also, and you will get some other equation. All right, but at the end,
Okay,
solution will be same. Okay,
okay.
okay. So let's solve these problems. So first, which of the following is not a type of matplotlib plot? So we saw that line is obviously there, right? We plotted line. You can do scatter and bar chart. I think bar chart was done in the lectures, histogram basically, right? And you can do scatter plot also, which is just dots everywhere. Pie chart is something that people generally don't use. Maybe that's why it's not part of matplotlib. I don't know, but pie charts are rare. Okay, so the answer is C. Now, this is the most difficult question of all time. What is the purpose of X label and Y label functions in matplotlib? To add a legend, to add a title, change color, or to label the axis, right? So, obviously, to add a legend to a plot. Answer is A. Next question. No, it's fourth. Okay, label. Third one. What is the purpose of subplot function in matplotlib? To create multiple plots, to adjust the size, change the color, add annotations. So we saw, right, subplots are for creating this multiple plots, grid of plots. So answer is A, really. Fourth one, which mode will write data to a file if the file does not exist? W plus, R plus, both W plus and A plus, and none of the above. So we saw that W obviously works, right? And R plus does not work because it's going to read, but there is no reading. Okay, but W plus and A plus will work because A plus will try to append, but if there is no file, It will create a new file and then append. Okay. Now select the statement that is not true for R plus mode. If the file does not exist, it gives an error because it wants to read, and then there is plus, so it can write, but it has to read, but it cannot read if it does not exist. So you can try it yourself. If you use R plus for a new file, it will give an error. So the first one is the correct statement. Others are obviously wrong. Both reading and writing can be performed. No. And if the file does not exist, it creates a new file and existing data is not truncated. So this is wrong. Others are correct. Which one is the following advantage of using with close while opening a file? Which one of the following is the advantage of using with close? And I did not cover it, but as I mentioned, you don't need to close it, right? So when you write with, it automatically closes at the end of the indent. So the correct answer is the file is closed automatically. Alright, ignore the grammar. I don't know who wrote the questions. It's from some older assignments. Okay, this one is the only one that requires some amount of calculation. What is the relative error for addition of x and y? And the error in measurement of x and y is epsilon x and epsilon y. Alright, so this they don't mention whether it's relative or absolute, but we'll take it to be relative. Okay, that's how it is in the lectures also. So how will it pan out? Maybe some of you can try. I'll give you a minute. You can type it in the chat box. So in x it is epsilon x, in y it is epsilon y, and r is x plus y. Okay, so the thing to remember is that I have some variable a, then its computed value or measured value would be a times 1 plus relative error. Okay, this is the formula that professor uses, right? Because you can do the algebra. So we have x and y, and r is x plus y. So computed value of RC will be real value of R, actual value, times 1 plus error in R, relative error. And that can be computed as xc plus yc. Alright. So xc, again using the same formula, it is x times 1 plus epsilon x. And this is y times 1 plus epsilon y. And what we want is this epsilon r, relative error, right? So if we expand this, this is r plus r times epsilon r. This is x plus epsilon x plus y plus epsilon y times y. Okay, and r is equal to x plus y. That is given. That is the quantity we are interested in. Okay, so only the error part remains, right? That's why what it should be happening. So epsilon r is going to be epsilon x divided by r plus epsilon y divided by r. Okay, so this is the relative error, and if you compute rc over r, which is 1 plus epsilon r, then it will be 1 plus whatever this is, epsilon x over r plus epsilon y over r. Okay, but the relative error is this one. And it's always a good idea to make sense of the answer that we got. let's say the error in x and y are 0, then the error in r should be 0, right? So epsilon x and epsilon y are 0, then you have the true value of x, true value of y, so you get the true value of r. So if those two are 0, then epsilon r should be 0, and that's why it's a sort of linear combination of epsilon x and epsilon y. Okay. And if you are adding two quantities x plus y, and if x is very small, then x does not matter so much as y, right? So that's why you have this coefficient x and y. Right. So now look at the options. 4. Okay. Yes, Nisha, you have a question?
Uh, yes, could you just explain that third line again? How did
Yeah.
that xc plus yc come?
So this thing yrc is equal to xc plus yc.
Yeah, RC R into 1 plus epsilon R equal to xc plus yc.
Yeah. So I'm using two
Yeah.
formula. One is rc is equal to r plus r into 1 plus epsilon r. Okay. This
Okay.
is definition of epsilon r, right? And the other thing is rc is equal to xc plus yc. Why? Because r is equal to x plus y. So real value of r is real value of x, real meaning actual value of x plus actual value of y. And now I am doing some measurement or some computation, and I am trying to compute this RC. So obviously that will be equal to sum of the value of computed value of x and computed value of y, right?
Yes.
So now I am equating these two terms because these are equal. Okay, is it
Okay.
clear? Okay,
Yes.
great.
Yeah. Yeah. Okay. Thank you.
So the correct answer would be second one. Okay, and that's why I mentioned about this sanity check. If epsilon x and epsilon y are 0, that means there is no error in measurement of x or y, and there won't be any measurement error in r also. Okay, so if you look at the rest of the options, it's 1 plus this epsilon. So in that case, the answer would be 1, which is wrong. So if you encounter such questions in your those silly exams for entrance of PhD or whatever, then you can just use these kind of little tricks. Okay, next question. It looks big, but it's very easy. Differential equation is given by this. Yeah, it's a forced harmonic oscillator. So you have d2x by dt2 and no drag term, and then restoring force omega naught square times x, and then a forcing term f0 by m cosine omega ft. So omega 0 is called the natural frequency, f0 is the amplitude of forcing, and omega f is the frequency of forcing. And how do we non-dimensionalize time of the above equation? So we need to compare two terms which gives you some time, right? And as you can see, uh, the first one is with omega 0. So let's compare first two terms which has omega 0. So d2x by dt2. By the way, what would be the dimension of that? It's acceleration, right? So meter per second square, length over time square, is equal to omega 0 square times length. So length will be cancelled, and you get 1 over time square is equal to omega 0 square. So time is the dimension of time will be dimension of 1 over omega naught. Okay, so that will be your t0, and then you write t is equal to t prime into that t0, the time scale. So maybe I should write it down. So I have d2x by dt2. Okay, and I'm comparing it with omega naught square x. So this dimension would be dimension of x divided by dimension of t square. Okay, just for remember that just because we have 2 here does not mean we have x square, right? Acceleration is just meter per second square, and this is the dimension of omega naught square times dimension of x. So this gets cancelled. We get dimension of time is 1 over dimension of omega 0, which by the way you can already imagine, right? Without anything doing any of these things, frequency is 1 over time, so time is 1 over frequency. So that means we can set our time scale as 1 over omega 0. And there was this question, okay, how do we set the time scale? So in this question we have omega 0, we also have omega f. So we have two time scales, 1 over omega 0, 1 over omega f. If they are close by, then both time scales are same and you can do any of that. If they are very far, then it depends on when you want to see it. If you want to see in order of milliseconds, and let's say this is 1 over milliseconds and this is 1 over years, then in for milliseconds you should use this time scale, so 1 over omega naught. If you want to see the long range behavior, you should use this one. Okay, so in any case we have this one time scale which is 1 by omega 0, which means we can non-dimensionalize using t is equal to some other variable tau or t prime as they call it. Okay, and times t0, that's it. So t prime is 1 over omega naught. So this is how we should start non-dimensionalizing our equation. So the correct option is the first one. Okay, there could be the other options could also be true, but since it's MCQ, the first one is definitely true, and you can check yourself if others are true or not. Even dimensionally, you can see that there is only one correct answer. Alright, so that is clear, right? Okay, this one again looks big, but it is not. The Schrodinger equation, this we already solved, right? So it is h square by 2me. I think it should be h square. I don't know why it's not there. Times gradient square phi minus e square by r phi is equal to e phi. Now where what is what, and then what is the length scale and energy scale. So energy scale is pretty easy if you look at it. You just have to stare at it. If you compare these two terms, phi gets cancelled. On this side you have energy, this side you have e square by r. Okay. So if you know the scale for r, which is Ra by definition, then energy square is just E square by Ra. Okay, and the question makers are also smart. They know that you can do it. So that's why it's there in all the other options. For Ra, you need to compare the other two terms, right? So you say h square by 2me, and this del square will have 1 over r square term, and that is equal to e square over r. So if you equate this, 1r will get cancelled, and if you put e square to the left downstairs and take r to right upstairs, then r becomes h square by 2me square. Okay, so the length scale is h square over me square, and those factors of 2 or 5 does not matter, right? Because it's just a scale. So we are saying whether it's meters or centimeters or nanometers. So 1 meter and 2 meter have same scale. Okay, so the correct answer will be the first one. And remember there is a square here, square. Okay, is that clear or should I work it out? I think now you should be able to do it on your own. Okay, and the last question. Again, Not so difficult. You have a damped oscillator with some damping coefficient, some drag, and then restoring force, and then there is some forcing. What are the time scales of this equation? So now you can see there are two time scales. And how do you get them? By comparing different terms. So the first one involves m and gamma. So let's compare the first two terms. So this is m times length over time square, and this is length over time scale, time. So one time will get cancelled and length will get cancelled. So if you take time to the right side, it is just m over 2 gamma. Okay, so it is m over 2 gamma, or you can write m over gamma, same thing. And the other could be square root of m by k or square root of 1 over k. And you can, right, time period of spring mass, it's square root of m by k, 2 pi square root of m by k. So this is the time period. How do you get it? Just compare first and third term. So again your x gets cancelled and you have t square. If you take it to the right hand side, it is m by k. So t square is m over k. So t is square root of m by k. Okay. I'm intentionally not working out explicitly because these are the kind of things that can be done in head. So it's a good idea to do it in head. Okay. So any questions?
Actually, I have some doubts.
Yeah.
So while uploading this video on YouTube, so can you share the Google Drive link?
The Google Drive link, I can share it to you
In
right now.
Yeah, in description
In
of that.
description. Yeah. Oh, that's a very good idea. Thank you. I will do that.
Okay. And then I have some other questions
Yeah.
regarding this final exam. So regarding that exam, so I have to write the coding right in the
Mhm.
final exam, and then how will be that exam?
I'm not very sure if you have to do the coding. I will not say no, you don't have to do coding. I will confirm it with professor and the NPTEL people.
Okay.
Because generally NPTEL courses don't have the coding component. So I don't know if they are going to organize some special kind of exam. Or because in assignments also you see there are no coding questions. So maybe it will be just MCQs. Nonetheless, I will confirm it and let you know the final thing. Okay.
Okay, thank you.
Yeah. Anybody else? Okay, if not, then uh, goodbye and let's meet again. Same link, same time, next Tuesday. Bye bye.